Hello, I'm going to get started by looking at these 5 flipped classroom problems. Depending on which calculator you have, depends on exactly how you can type this in. But assuming your calculator has some sort of double E feature. So in the case of this guy, the double E you have to hit the yellow second before you hit the double E. This calculator, not as useful. This calculator, you can hit a x10 to the x. Not as useful as the double E. Doesn't work perfectly all the time, but it does work to some extent. And there is this guy, which is the guy I'll use, which has the double E just right here. So, and you don't need a graphing calculator to do these math. You just want to be able to set them up. So, the first few set of problems is converting moles to atoms. So I'm always going to start with my initial number over 1. This is given a unitless 1 so that I can make sure that I know which way to cancel. I've given everyone Avogadro's number. So I'm going to set, since I have 1 mole, Avogadro's number says 1 mole is equal to 6022 times 10 to the 23rd molecules or atoms. So molecules of water and 1 mole of water. Setting that up means these cancel, and I just multiply my way across. I can just say 13.5 times 6022 times 10 caret 23. And I get the answer of 8.13 times 10 to the 24th. Could I have done that a different way? Absolutely. 13.5 times 6022, hit E, 23. Same answer, 8.13 times 10 to the 24th. Both work. Turning this, set that over 1. Since there's 1 mole up there, we want 1 mole. Since there's 4 moles up there, I want 1 mole of nitrogen down there. How much is that? That's 6022, 10 to the 23rd. That's molecules of N2. Moles, moles. Just multiply my way across. 4.31 times 6022 E23. 2.5, we'll say 2.60 times 10 to the 24th. Now, setting up this guy. Since this is molecules up here, set that over 1. I want molecules down here and moles up top. Molecules. Well, actually, sorry, atom. That should be atoms because it's helium. Atoms. That doesn't change anything in the answer, just how we're looking at this. For 1 mole of helium. Well, 1 mole of helium is 6022 times 10 to the 23rd atoms. Now, atoms and atoms cancel out. Please note, this is a big number. However, this is a bigger number, so you should get a small number. 8.82 E19 divided by 6022 E23. Now, my computer fell asleep real quick. So if I hit the equals, it gets that. Now I'm going to turn that into, see if I can turn that into scientific. I'm trying to figure out if I can with that. Well, I'm not sure I can very easily, so we'll just leave it as it is. We can, oh yeah, second scientific. I hit the second and the side button, and that gives me, oh, it's 1.46 times 10 to the negative fourth moles, which is very small, but that's fine. That is acceptable. I'm going to use a different calculator now. If I can find my other calculator. Oh, there it is. Just as an example. 2.74 times 10 to the 28th. So set that 1. This is big number. I'm dividing by a big number, but it's slightly smaller big number. 10 to the 28th is bigger than 10 to the 24th. Set that up. Molecules, molecules. Now, the reason I wanted to use a different calculator is so you can see if I put these both in parentheses, 2.74 times 10 here, 28 divided by, in parentheses, 6022 times 10 23rd, I get what is essentially 4.55 times 10 to the fourth moles. A big number. Now, there's many different ways to type that in. 2.74 second E 28 divided by 6022 second E 23, same number. However, if I type this in like this, without the parentheses, 28 times 10 to the 23rd, notice it is a very big number. Much, much bigger than this number. Instead of 10 to the 4th, it's 10 to the 50th. So be careful. Last problem. If I have this many molecules of butane, how many moles of carbon would I have? So step 1 is to convert this into moles of butane. Well, we have 6022 times 10 to the 23rd molecules of butane and 1 mole of butane. Butane. Okay. So that cancels that. And the next step is where most people are struggling on. Well, what do I go from there? Well, in 1 mole of butane, how many carbons are there? In 1 mole of C4H10, there are 4 moles of carbon. So this and that cancel. So we're left with moles of carbon as my final unit. So as I type that in, I'm going to say 3.29 second E 24. Now you could either divide by this first or multiply by this first. It does not matter. You will get the same answer. So if I times by 4 and then divide by 6022 second E23, you're going to get 21.85, which can round to like what? 21.9 moles of carbon. If I do it a different way, if I say 3.29 E24 divided by 6022 E23 and then times by 4, still get the same answer. It's when you get dicey with it and put in weird parentheses that you can get off. Let's see. So if I keep them in the correct order, correct notation, you can still get the same number. So that last way I typed it, and that is where I'm going to leave you, is I can break this down into 5 different inputs. 3.29 times 10 to the 24th times 4 divided by 6022 divided by 10 to the 23rd. These are on the same side of the equation. These are on the same side of the equation. That is another way to type that in. But that is where I'm going to leave you, how to do all this.